Let us start with the most successful second generation system, which is GSM. GSM started in the early 80s and originally was called Groupe Spéciale Mobile. This is why we have the acronym GSM, and today GSM stands for Global System for Mobile Communication. So the idea there was the European countries wanted to create a pan-European standard. The standardization organization is ETSI, the European Telecommunication Standardization Institute. ETSI also created standards like TETRA, like DVB, and many, many more. The idea there was, we want to introduce in different European countries certain services for mobile communications in different phases. And Germany, for example, the first networks were called D1 and D2. And the key idea fits to the idea of the European Union that we have a seamless roaming. So no more borders, also for communication systems. Before that, you could not simply use your mobile phone in other countries. Well, you need other contracts, maybe other phones, other frequencies, whatever, quite complex. And the GSM was the first system where you could have a seamless roaming. Roaming means you will have a connection with a different network operator. We will learn that we have national roaming and international roaming. National roaming means you switch from one network operator to another one in the same country. And international roaming means you switch from one operator in one country to another operator in another country. So that was the key idea, and it took roughly 10 years before the first products were available. 2008, you had many providers all over the world, more than 200 or 220 countries and territories. Basically all countries in Asia, Africa, Europe, Australia, America, many billions of subscribers, more than 700 different networks, and you could do exactly this seamless roaming. So not only in Europe, but worldwide. And this was the key to success. A single mobile phone you could use for many different networks in many different countries. And the user does not really notice this. That was the really basic idea. So 2008, more than 75% of all digital mobile users, they used GSM. There were some other networks, but the big majority used GSM, the former European standard, now used worldwide. So this is one of the biggest success stories also for a European product. 2008, we had more than 29 billion SMS sent in Germany, and that was contributed to more than 10% of the revenues for many operators. So rough numbers, but you see, that really was very, very important 12 years ago. What happened since then? Well, just to show you one thing about SMS. So 2008, there was still an increase. 2012, we saw the peak. And then we started with all the messages. So all these, 3Ms and WhatsApps and Telegrams and iMessage, etc. Messages that require internet connectivity. So the first mobile phones starting 2010, 11, 12, they suddenly had internet for email, for many other purposes. So IP connectivity using internet protocols. And this means, you can simply use messaging. You used in, your normal laptops, desktop computers, you could now use on the mobile phones. So you don't have to use SMS anymore. And the problem with SMS was especially that you had to pay for it. So paying for SMS, and now you have a messaging service that's basically for free. Well, we all know we pay with our data. So you don't have to pay per message. And this was actually almost death of SMS. But we still see SMS. So maybe it's somewhere here. If you look at the curve, so it flattens out somewhere. We still have SMS. There are several reasons. So there are, for example, machines that operate on SMS, because you can send controls, commands via SMS, and the machines can send status reports via SMS. And SMS is a very simple technology that operates without the internet. So if you have real bad connection, you at least have something like an SMS service. So maybe you don't have data connection. We'll come back to what data means, GPRS and all of this. But as soon as you have network coverage, simple coverage of a GSM network, you have SMS. Because SMS is a kind of integral part of the signaling system in GSM. So maybe in the future we will not see 3G networks anymore. Maybe we will not see big data service on 2G networks. We'll only have 4G, 5G, whatever networks. But maybe we will still have some basic GSM coverage for traffic signs, for vending machines, for certain whatever smart home alarms, etc. So we will see what happens to SMS. And by the way, SMS is the only way you can use to reach a mobile phone from the outside. All the other services like messaging, they require the mobile phone to set up a connection to some servers. But if the mobile phone doesn't want to do anything, but is connected to a network, not to a server, no IP, nothing, you can always use SMS to contact the mobile phone. That's an important feature, for example, the police can use to localize someone. Okay, so we will see what happens to SMS. So now let's go back to the early 80s, mid-80s, early 90s. That was a time when the mobile phones still used analog technology. So what was the idea for the initial GSM system, always compared to classical analog systems? Well, we want to support voice and some, data services. Okay, 9 kilobit per second, for example. It should be mobile, wireless, and that was really a clever idea. We want to have something like a total mobility. We want to be able to use the system no matter what network operator actually covers a certain region. And the idea there was we integrate a chip card that enables the use of access points of many different providers. We will see how this works. That was the idea of the SIM, the subscriber identity module. So the idea there was to separate the identity of the device from the identity of a subscriber. I will explain this in more detail. Then we want to have one number. Today you would say, oh, what is special about this? Yeah, this is a mobile phone network. But this was a new idea many years ago. The network has to handle localization. Before that, in the first networks, you had to know, the number of a user depending on where the user is, the city, for example. So you had to dial a certain prefix depending on the place someone is. But if you don't know this, how should you localize someone? So that was difficult. So, and compared to analog systems, the inventors want to have way higher capacities, better efficiency, smaller cells, more customers per cell, better transmission quality. So at that time, high audio quality, better reliability, and, quite important, uninterrupted phone calls at higher speeds. So 250 kilometers per hour on a German highway. So that was one of the ideas from cars, trains. That simply does not work with simple analog systems. So you have a lot of noise there, interrupted phone calls, etc. And then there was already the idea for some security functions, access control, certain authentication, a PIN. Remember, compared to a fixed phone network, now you suddenly have a mobile phone and not a fixed phone. So, and as all the customers are evil, the network operators wanted to protect the network from the evil customers. Okay, so this is why we need some security functions. Well, we also have many disadvantages, especially when it comes to security. So there is no perfect system. For example, no end-to-end encryption. Because compared to a fixed phone network, why should we have end-to-end encryption? There is no end-to-end encryption in fixed telephone networks. And inventing a new system does not necessarily mean we have to make it better and within all ways we can think of. So maybe we want just to have a mobile and wireless replacement for the fixed phone, but not a high security device. So there's no end-to-end encryption. We also do not have the full ISDN bandwidth. So ISDN in the 80s was the most dominant digital telephone network. And it already offered 64 kilobit per second to the user. Transparent end-to-end. Not with GSM. We cannot offer 64 kilobit per second. Okay. Then we had the problems we still have today. So using a mobile phone network while driving is a bad idea. We have certain electromagnetic radiation close to your brain, etc., etc. Is this a problem? Yes and no. Big discussion. Abuse of private data. Yes, we have roaming profiles. We have certain metadata. So the network operator precisely knows where you are. Well, precisely. It depends. But knows where you are. The system is really complex. I will just show you some ideas behind the system and you will understand why this is complex. And many things in the standards were optional. So some of the devices had some capabilities, some others not. Some operators had some more features, some others did not have. So there are many disadvantages, but also big advantages. So before we go into all the details, I will give an overview of what GSM offers. Think back, 80s, mid-80s, introduced early 90s. So 30 years ago. What is the basic idea? The basic idea is of GSM, we want to offer certain mobile services, different types of connections, so voice connections, data, and a short message service. And we want to combine different services. So what is the idea? If you look at the figure, it basically shows a, for example, digital fixed network. Most countries at that time had ISDN networks. So that's a integrated services digital network, a digital telephone network. There was also the classical old analog network. But in the 80s, that was roughly the time when most countries went from analog to digital fixed networks. Then we have a GSM public land mobile network, many acronyms. So that means there is something in addition to the fixed network. Okay, there's some destination network, we're not interested in this. And then the architecture and those blocks in this diagram, they follow the basic setting of ISDN. There's an interface. Here it's called UM. In ISDN, it was the UK0, so that was a copper wire. So that is the air interface, UM. That's the interface. That really is the air interface. And then we have the mobile station, MS. I know, mobile station, that is strange acronym because mobile and stationary, but that's the acronym, mobile station, MS. And the interesting part in the design is that the mobile station here consists of, let's say, a normal ISDN telephone plus kind of a modem for the wireless technology. What does it mean? You can offer certain so-called telematic services end-to-end between ISDN telephones, and no one, the users, the devices, will notice that we have a wireless network in between. So I will come back to the telematic services. So that's the interesting part, that we basically have ISDN telephones now with a wireless part in between, but you will not see this from the point of view of the telematic services. We have certain bureau services. I will come back to this as well. That's between the endpoints RS. So there's a certain hierarchy of interfaces in ISDN. I will not go into the details, but there we can say we have a certain data rate. And MT, that's our mobile termination, that's our modem. And this modem, modulator, demodulator, is actually the component that translates our bits into this wireless technology. Okay, so what we have is an ISDN network, and we add a wireless component, and that includes modulation, demodulation, but also localization technologies, certain databases, etc. But in the end, GSM was an add-on to ISDN. So most of the countries that already had a digital network based on ISDN technology in the core, they decided to go for GSM as the wireless mobile extension to ISDN. And that was also part of the success for the GSM technology, so you don't have to install a new whatever fixed network. Okay, now let's go back to the services. So first of all, we have so-called bureau services. So these are services to transfer the bits, transfer data between the access points, the R and the S. And there we have the classical OSI layers 1 to 3. And they specify physical layer, data link layer, and network layer, how to route a call, how to start a call, how to create a connection, how to tear down the connection, etc. So these are all the protocols we need to set up a transparent pipe between two endpoints offering different data rates. So the original standard offers circuit switching and packet switching. And for example, you can set up a circuit switch data service with 9.6 kilobit per second. That's what we can use for fax later. So the classical data rates are in this, 2 to 10 kilobit per second. Not much compared to today's phones, but this is how it all started. GSM, the classical GSM, offers today up to something like 50 kilobit per second, not more. For higher data rates, we need other modulation schemes. So this is how it all started, 9.6 kilobit per second. Based on these services, we can offer certain tele services. So tele services, they offer, for example, voice communication based on this bit pipe. There we have to obey cellular functions, certain security measures, etc. And most important at that time was the mobile telephony. So using the phone really for calling someone. That's new maybe for the younger generations. You can call someone and not only, use some messaging services. So that was the primary goal of GSM, enable mobile telephony. The traditional bandwidth, 3.1 kilohertz, that's roughly, if you look into the spectrum, Then if you look at the male voice, main energy somewhere between 400, something like this, or 400, 300, whatever, and 3000, whatever, 500, something like this, hertz. There's the main energy, and for male voices, different for female voices, and this is what the classical engineers wanted to transfer in the analog telephone systems, and so that was the idea there to transmit this. And that, by the way, is the reason, okay, if let's make it 4 kilohertz, and you code this with 8-bit, and you use a certain sampling rate, we end up at the 64 kilobit per second of ISDN. On the US, it was 7-bit, 56 kilobit per second. So, but that's for fixed networks. So that was one of the primary goals, mobile telephony, with a good quality. And then something really brilliant at that time. Today you say, yes, all mobile phones have this, but at that times, that was really something new, a common emergency number throughout Europe, 112. If you look at the different nations, we still have different numbers worldwide. We have 110 for the police in Germany. We have the 911. We have, and now think of many other numbers. But if you are a tourist somewhere, you don't want to remember different numbers. You just, either dial 112 or you just push emergency. But that means a lot for the system. Not only this is mandatory for all the service provider, this has to be free of charge in all the countries, but this is also the connection with the highest priority. So this emergency connection can actually preempt other connections. So, kick out someone else from the network. So that's quite interesting. And the network has to do a lot more in the background, because if you dial 110, you want to have the ambulance closest to you to come, or the police closest to you, not the police from your home country. So depending on the place where you are with your mobile phone, the police closest to you should be alarmed. But this requires a lot for the system in the background. Think of that. So you need certain localization technologies, a lot of database lookups, etc., etc. Also, preempting other calls, that's something that has to be really built into the network. That's quite interesting. I will come back to some of the features of GSM later. And then there's another service called multi-numbering. So you can have different phone numbers for the same device. That's something we use pretty much in a way we actually see this, so call forwarding, etc., but also in an invisible way, because the classical network doesn't know anything about the mobility. Your mobile phone will get a kind of a so-called topological correct phone number. If you're in Australia, for example, your mobile phone will have an Australian phone number so that the routing works in the network. But what is visible is your phone number, independent on the place where you are. I will come back to this as well when I discuss setting up a call to a mobile user. We have some additional services like fax. Many years ago, using a fax was the fastest way of sending a copy of something to someone. Today, we produce the documents in an electronic way using some word processing, and then we send an email or use whatever there is. Or, in case you have a real document, then you scan it and send it. So fax devices are not that important anymore, but it was integrated there. Mailboxes, voice mailboxes, was already there, early 90s. electronic mail, not the internet mail we use today, but there was also a mailing system there. And then SMS. You saw that SMS was very prominent, but in the beginning it was almost ignored. So there were some engineers saying, okay, nice feature, why not having something like a short messages, some characters we can transmit using a certain channel, so-called signaling channel. Like in the classical telephone networks, we have the separation of the signaling and the user data, clearly separated. So-called control plane and data plane, clear separation. That's typical for the classical networks, not in the classical internet. In the classical internet, signaling and data, as you maybe learned in computer networks course, is, well, in the same channel. And today we all talk about, well, the new technology of software-defined networking, where we start separating signaling and the data planes again, but that's something different. So, SMS is sent over the signaling channel, and this is why you always have SMS independent of any data service. SMS is there as soon as you have connectivity to a GSM network. So it was ignored in the beginning, and then it was one of the most successful add-on. So in the early days, SMS was handled by a single PC for the network operators, and they made a lot of money out of this. And today, you typically use some IP-based messaging, and usually not SMS, because some operators still charge for SMS, which is kind of strange because messaging is for free, and all the efforts to introduce some messaging where you have to pay, well, they all were failures. Besides Bearer and Tele Services, there are some supplementary services. So you cannot offer them stand-alone, but these are similar to some other ISDN services. They may differ between different service providers, countries, etc. But something like forwarding numbers so that you see numbers on your display, but also suppressing this forwarding. Think of that. The system always knows your number. So you cannot suppress forwarding your number into the system. The system has to know your number. That means the police also knows your number, but maybe not the other end device. The end device on the other side might not see your number. Okay, then there's functions like automatic callback, conferencing, locking the terminals, incoming, outgoing calls, etc. So some additional nice features we may use in the context of mobile phones. Now, before we go into the details of the architecture of GSM, some questions, some tasks for you. So what is SMS still used for? Can we replace it completely? What do the replacements require? No, there are still maybe some problems. Look into that. Why was GSM such a big success? Now look at some of the other systems. I mentioned some in the overview. So what contributed to the success? If you look at the differences between fixed networks, digital phone networks, ISDN, and GSM, what are at a high level the main differences? Maybe they also contributed to a success part. And then think again of the emergency number 112. What is required in the background? What do we need to provide worldwide unique number? Finally, look once more at the characteristics of GSM, the disadvantages of GSM. Now, if you look back, what has changed? And what is the same if you compare GSM with today's systems? Do we still have the same disadvantages, same characteristics? So what has changed and what basically remained the same even today?